today's a great day. It's a birthday, and a great piece of software that's been that's been created last year is turning exactly 1 year today. And this next talk is about that. So give a big round of applause for Ravi and Yawen.
All right, good morning, everyone. It's great to start off the second day of OSFC 2019 with a birthday party, right? So whose birthday it is? It is a Slim Bootloader, a firmware that Intel created and innovated just last year, right? So my name is Yawen. I'm a firmware engineer from the Internet of Things group from Intel. And together with my colleague, Ravi Rangarajan, we're going to share with you what we have learned, what's coming next, and also the key learnings from Slim Bootloader. So today I'm going to share with you, again, a little bit introduction, a recap, just in case you weren't there last year, about Slim Bootloader, what it is, and also the updates that we have done, what we have learned, what's coming, and a call to action. All right. So last year, OSFC 2019 in Erlangen, Germany. So I shared during the lightning talk of Slim Bootloader, I introduced to the world about Slim Bootloader, its value, and the Intel team were there. We even had a demo working on Slim Bootloader on one of the Apollo Lake systems. So that was last year. And if you're interested in that talk, the slides are available from OSFC 2018. So these slides will be shared to you and with the links provided. All right. So first things first, what has changed? We have a new logo, right? So anyone can guess what animal is that? It is a hummingbird, yeah. So it's a hummingbird. We chose the hummingbird because it represents Slim Bootloader, the principal architectures. It is small, it is agile, it is swift, right? So it represents our product called Slim Bootloader, and we have variants of colors and backgrounds that comes with it as well. And if I'm not mistaken, the stickers of Slim Bootloader are still outside, so feel free to take them. All right. So let me do a quick recap of what Slim Bootloader is again. So before we have Slim Bootloader, in the Internet of Things use cases, we have from Intel side, we have customers with very wide range of use cases and also requirements. And back then, we found that there's actually not one boot firmware that fits all these requirements. What are them? Ease of implementation, how easy it is to port a boot firmware to their Internet of Things application and use cases. Security is a concern, how safe it is, and how extensible it is. Can it boot different OSs, add-on features, advanced features? And also scaling across market segments. When we talk about Internet of Things, there are so many market segments from industrial, automotive, and so on. Also, licensing is a concern. We need to have an open source solution that is permissive to our customers and also ecosystem partners. And lastly, it leverages the Intel firmware support packages so that the adoption of new SoC and platforms is easy. So since we have launched Slim Bootloader and get feedback from customers, it is getting a lot of attention, and also from the customers, from the partners, and also from the community. So what is the value proposition of Slim Bootloader? Firstly, as I mentioned, Slim Bootloader is designed to enable new experiences so that it is for the customer-centric innovation and can be used across a wide variety of use cases. So the 4 pillars of Slim Bootloader is that we can do fast boot, it boots fast. In Intel, with some optimization, we can achieve sub-second boot from reset vector to OS handoff. Security is integrated. By default, Slim Bootloader comes with verified boot, measured boot, and the firmware update payload also can perform firmware updates with security for you. And thirdly, the permissive licensing. So Slim Bootloader comes with BSD plus patents license, and we found that it allows our customers and partners to add on their value-added features and their proprietary customization. And lastly, it is ecosystem-wide support, so we enable for customization and maintenance easily with Slim Bootloader. So with this, SBL can be used in many use cases because of its features. It is very highly adaptable, customizable, And for now, it's IoT focused, but we see no problem if you can scale to other market segments as well. Like I mentioned, industrial, automotive, smart cameras, that's about anything. So when you download Slim Bootloader, this is what you get. So the boxes in blue are the one that comes default with Slim Bootloader. Firstly, it comes default with 2 different payloads, the OS loader and the firmware update payload on the top. And it has speed optimization hooks that allows you to perform some optimization. Firmware update allows you to have a fail-safe firmware update. That's a backup redundancy copy integrated with it, and integrated with verified boot, measured boot. And of course, it consumes the Intel FSP silicon initialization block. And on the right side, as you can see, it also comes with default with a configuration editor tool. So in the third talk today, which I'll also be sharing, I'll show a quick demo of what this tool does. Basically, it allows our customer or partners, OEM partners, to customize Slim Boot without even looking at the source code. So if a customer or partners wants to change to a different payload, UEFI payload, for example, or U-boot or anything, so they can easily plug in into Slim Bootloader without any problems. All right. And Slim Bootloader is supported across all the Intel architecture platform from Atom all the way to Xeon. So since we have launched Slim Bootloader a year ago, we have engaged with our different ecosystem partners, and this is the list. And these partners provide customization, extension of features, and also maintenance services. And I actually see some of them here in this conference, and I would like to thank them on behalf of Intel. All right. So right now, I'm going to pass the time over to Ravi, and he's going to share with you what we have learned from Slim Bootloader and what's next. Ravi.
Thanks, Yavan. Thanks for the recap as well as the introduction. My name is Ravi Rangarajan. I'm a firmware architect for Intel. Specifically, I work for a group called IoTG. And as Yavan mentioned, we created a Slim Bootloader last year to cater to some of our IoTG specific use cases. So the next few slides, I would like to share with you the progress we have made so far since launch last year. What are our key learnings as well as what's next for Slim Bootloader. So last year when we launched, am I pressing it wrong or something? Okay. So last year when we launched Slim Bootloader, we actually had support for 2 different platforms, right? So the first one was the Apollo Lake SoC, and we supported 4 different boards. 3 of them were from IoTG, Leaf Hill, Mineral Hill, and Oxbow Hill. And we also supported a virtual platform, virtual Intel platform supported on top of QUMU. Since then, our team has added support for these 2 new silicon, Coffee Lake Refresh, and we support 2 different flavors, S and H, and Intel CRBs are the reference platforms for those. We also support Whiskey Lake, and as usual, we support Intel CRB with Whiskey Lake. But on top of that, we also support Up Extreme board from AEON. So yesterday, there were a few mentions of Up Square board from AEON. So Up Extreme board is the next iteration of that. It is with Whiskey Lake. I don't think it is still available for purchase yet, but you can pre-order them if you're interested. This is a publicly available hardware. It's kind of semi-open, so anybody can purchase it, and it's not locked, so boot guard is not enabled. So it's pretty suitable for developing your own firmware if you want to experiment, if you want to hack the firmware. So this board is available. So I would like to make another note here. So specifically from IoTG, based on the market responses we have seen from our customers, from community, our plan of record, our intent is to support Slim Bootloader across all POR platforms for IoTG. As Yavan mentioned, covering from Atom, Core, and Xeon. So when I talk about Xeon, there is an exception. So we talk about Xeon D, the density addition SKUs, and not the SP, the scalable platform, dual socket or multi-socket platform. So Slim Bootloader is POR across IoTG roadmap. So as for the major new features, we added support for boot guard and SGX. So this is a critical security feature. It is an optional feature. I know it's a polarizing topic, but so boot guard, what it does is it actually verifies your initial boot block. without requiring you to have any other special hardware protection for your boot block. Some people like it, some people don't like it that much, but it is available, it has been enabled. As part of enabling, we actually support creating the necessary data structures. So that there are data structures for creating the manifest of the boot block, which an authenticated code module from Intel will verify. And only if the verification is successful, it will allow it to boot. So there, the infrastructure for enabling boot guard is in place in Slim Bootloader. It has been upstreamed as well. But as usual, there may be some binary blobs that you may have to get it directly from Intel to enable that. SGX support has been added. Discrete TPM and firmware TPM, the PTT support has been added as well. We were able to test discrete TPM on both the LPC bus as well as the SPI. Debugging capabilities. Yesterday, there was a whole talk on debugging. The focus these days is towards a closed chassis debug, right? So when we are debugging within Intel, within any OEM premises, we have all the tools we need. We have JTAG debuggers, we can open the board, we can even connect a logic analyzer and so on. But how do you debug a production system? How do you debug a system that is returned from the field? So closed chassis debug is gaining attention, and Intel has enabled this technology, USB debugging, DCI OOB and DCI USB. OOB is out of band and USB is through USB 3. We have enabled these debugging capabilities in Intel Slim Bootloader. And on top of that, one of the requirements that we often hear from our customers and community is the ability to do source level debugging, right? I don't have a JTAG debugger, it's expensive, and I don't want to, my board does not have a JTAG port as well. So how do I debug? So you can do source level debugging through later in the slide, I'm going to talk about the leverage from EDK2, and this is a great example of that. So EDK2 project has UDK debugger module that you can use to enable source level debugging. We ported that over to Slim Bootloader, and it has been verified and working fine. IFI stitching mechanism. So this is another a bit of a contentious topic in this kind of conferences, but so we support two different types of IFI stitching mechanism, right? So one, let's say you get a reference board from Intel and you want to try Slim Bootloader. I don't have the rest of the components that make up the IFI. By the way, for those who don't know what IFI is, it's a Intel firmware image. So it's not just the BIOS binary. It is made up of a few other firmware ingredients as well, like CSME binary and a few other blobs, and some descriptor settings and things like that. So you get a reference board, and you can download the Slim Bootloader directly from the open source GitHub, and I'm able to build and everything. So I want to flash. So where do I get the rest of the IFI components? And I don't want to go through all these hoops to get the rest of the thing. In that case, we actually provide a mechanism for you to replace just the BIOS region with the Slim Bootloader binary you built. And on top of that, you like it, and then you want to go full-fledged on that. At that point, you actually contact Intel to get the kit, the IFI stitching kit. It includes certain tools like FitC and the other binary blobs that you require to create the IFI image. So you got everything, and then in that case, we provide a script that actually takes all these ingredients and creates an IFI image for you. The goal for all this is to make the job of creating an IFI easier, right? So, and if possible, even automate. If you have CI system and things like that, everything should be automatable. So new payload support. So one of the features that we allowed about Core Boot was the flexibility to support different payloads. And when we did a Slim Bootloader, we actually carried that idea over, and So when we launched Slim Bootloader last year, so we had our own default payload called the OSFC, and we had a firmware update payload. At that time, we mentioned that there is a possibility of adding more support, we went ahead and submitted a code review to U-Boot to build U-Boot as a payload for Slim Bootloader. It is currently under review. And we just updated our documentation yesterday. I don't know if the pull request was merged already. And then on top of that, we had a special branch of UEFI payload because the open source version of UEFI payload supported core boot, and it depended on certain data structures produced by core boot. So we went ahead and added support for Slim Bootloader as well, and payload has been unified. And as you can see, that there's a link here. You can go download it today, and you should be able to build and try the UEFI payload. Linux boot. I believe the next topic after this session is about Linux boot. And Ron and one of my colleagues, Lin Sheng, are going to talk about that. And I believe they're going to show a demo as well with Slim Bootloader and U-Boot. Yeah. So please stick around. Again, so the concept is payload is modular, and you can extend it to anything you want. It's not limiting. For example, if I want to develop a diagnostic payload, it is possible. One of the things that we are exploring within Intel, within our group, is to have something for functionally safe systems. So we are exploring a payload that goes and qualifies or certifies that the system has been initialized as expected. And it's not, I should not use the word certify, but it kind of goes and checks the system has been initialized as expected, and then qualifies the system for functional safety workloads. So there are many possibilities like that, and then we are actually looking at more ideas along those lines. Firmware update. Just last year when we launched, we supported update of the BIOS region alone. We have added a mechanism to perform ME region update as well. I think it was System 76 talk yesterday. They were actually showing interest in updating the ME region. Even if you have a skeletal version, ME is a required component as part of the EFI, and updating ME is a critical requirement. Again, so require CSME update components from Intel. The infrastructure is there. You may need some certain components that you need to get from Intel to actually enable that feature. Key learning. So we have had 1 year. We added a few platform support. We added a few features. And as I mentioned, going forward, Slim Bootloader is a plan of record for IoTG platforms. Moving forward in 2019 and 2020, I expect at least 2 or 3 more platforms to be added there. One of our goals is to build a community, but I'm jumping ahead of myself. But let's talk about the key learnings. So what did we learn from this effort? What did we learn from doing Slim Bootloader in general, right? So open sourcing helps with faster scaling. Everybody here understands the power of open sourcing, and Ron mentioned however smart you may be, you can be smarter than the rest of the world. So open sourcing is critical. Michael also mentioned about the ability to dispatch or deliver a security fix much faster, right? So working from the tip of the tree and things like that. It helps us. It helps IoTG to deliver new features, right? So bug fixes and everything. It's kind of real time. So once we submit a pull request, everybody can see it, and once it gets merged, it is there, and you can just go pull it. Roadmap consistency is critical. So this is something that we have learned as well. And I think, again, going back to the System 76 talk yesterday, he mentioned that it's a really critical point that we keep hearing from our customers, right? Once you do something, and we have heard it from our other customers also. So when they make an investment, they want to carry over that investment. I don't want to do one bootloader implementation, firmware implementation of this project, and then I don't like the rug getting pulled out under my legs, right? So I want to continue. Let's say I develop a driver. Like, simple example. There were a few references to developing some kind of a network boot driver and certain other things yesterday. So let's say I do go ahead and develop a driver. So I want to take that driver and then carry that over the next generation platforms as well. I don't want to go redo things for every platform. Similarly, my learning curve, right? So I spend time, I learn a particular code base, and I'm quite comfortable with that. I don't want to go do something else next year, right? So roadmap consistency is critical, and investments need to be carried over. So that's a message that we have received, and that's why I keep repeating the same point over and over again, that Slim Bootloader is POR for IoTG platforms. One round of developer experience testing was done by us. The process was really interesting. It was an eye-opening experience for me as well. So what we did was we partnered with a consulting company, and they hired a number of 5 or 6 firmware engineers who had firmware development experience, but not familiar with Slim Bootloader yet. So we hired them as a experience testing project, and we gave them a scenario, right? So the scenario was, assume you are a firmware developer for company X, and you are tasked with developing fast booting firmware for our upcoming platform. You hear that there is a new project called Slim Bootloader that is open source. Go explore that. So the time duration given was 2 hours or 3 hours. I don't recollect exactly. And then we tracked where they stumbled and where they had difficulty finding information. The learning for us is good documentation is a must. We went ahead and updated the documentation after that exercise, and we plan to do a couple of more rounds of the same kind of experiments in the next 1 year. Out-of-box experience. So this is critical as well. So as you all know, the amount of a developer pool available for firmware development is low relative to, for example, the amount of kernel developers you'll find for Linux, right? So how do we attract more people, right? So the out-of-box experience comes. It becomes really important. So when I provide a reference implementation and I say, here is a documentation, here is a board, this is what you do to get it booting, and if he follows the same steps, and the steps should be fairly simple as well. It should not be too involved. Let's say I give them a set of 10 steps, and then later today, Yavan is going to show a porting exercise demo. So if he does that, it should boot out of the box, at least on the reference platform, right? He should not stumble, it should not hang, or if it has an issue, it should be clearly logged and things like that. Once you have a reference implementation working on a reference board, then taking that and porting to your own custom hardware, adding new features becomes easier, because you're not daunted with just climbing over the mountain at the very first step, right? So you get into a rhythm, and then you can figure things out. So out-of-box experience is really critical. Cooperate with other open source community projects, EDK2, Linux Boot, Acon, U-Boot, etc., to provide value. As I mentioned earlier, so we already have a patch under review for U-Boot. EDK2 we have submitted. So EDK2 is like we share, we contribute both. It goes both ways, right? So EDK2, we have leveraged a lot of code, like, for example, the base libraries and things like that. They are well tested and available for use, so we leverage that. We have leveraged some drivers as well, like PCI NVMe driver and things like that. We have contributed to the UEFI payload from our group as well. So if there is something available there, don't have to reinvent it. We don't have that not invented here syndrome. We love to leverage as long as the licensing permits, and we would like to contribute back as well. Direct community engagement provides valuable feedback, right? So this is pretty obvious. So we have a mailing list, and we come to know various different use cases, pain points directly from our customers and the community. A recent example that I can quote is somebody was using a UEFI payload with Slim Bootloader. So the UEFI payload has variables, and they wanted to access the variables from Slim Bootloader, even though they are kind of different entities. So after hearing their use case, we thought, okay, maybe it's reasonable, and we heard that from a couple of other customers as well, and then we went ahead and added that support. So we get an opportunity to hear a customer feedback, community feedback, and during my closing remarks, I would say Intel in general welcomes community feedback. Please feel free to provide that, right? High leverage from EDK2 and Intel FSP makes it easier to enable new features and platforms. I think I hit on this point a couple of times already. So what's next for Slim Bootloader? Intel will continue to add support for future Intel silicon and platforms. And even though I say Intel, I just noticed it. I should qualify that IoTG group within Intel. So there are a few other groups, and they may have some different plans as well. So adding support for FSP 2.1. So again, Michael mentioned the evolution of FSP from 1.0 to 2.1. So 2.1 API mode does not have a big impact on consumers like Core Boot and Slim Bootloader, but still we have to go support the new version of the FSP info header and things like that. More payload options, enhanced configuration management. So as Yavan mentioned a bit ago, so one of the goals that we had, as I mentioned, was to lower the entry barrier, right? So actually, Intel Slim Bootloader was initially offered to an internal IoTG group. And one of the requirements they provided was quite interesting. So they wanted one binary to be able to work on multiple different boards. So we came up with this configuration infrastructure. It's a platform IDE-based configuration. And the desired goal was to see if I can take the Slim Bootloader, I can just change some configuration parameters without changing any source code. So it should not require rebuild. Can I try it on a different board? Especially from IoTG point of view, a lot of our customers take our reference design. They come up with their own layout, but not too much changes in terms of the hardware schematics and things like that. A few GPIO changes maybe all they make. Maybe they change the type of memory they support. So do I have to go change the source code to make all these to support these changes, or can I make these changes through a GUI tool and restitch, not rebuild, restitch, and can I support a new board with that? If the new custom hardware is closer to the reference design, this should be absolutely possible. There may be cases where you still may have to go change the code. You want to do that, that's fine. That's all allowed. It's all open source. But if you are a small company having one firmware engineer, I don't want to spend too much time on this, or my Linux engineer is doubling up as my firmware engineer as well, then getting things going is really critical, right? So there is a session later today, which will show a demo about the configuration management. Enhanced documentation. This is like a continuous improvement process for us, right? So we have a set of documentation. We have heard a lot of praise, good feedback about that. But we also realize as part of the developer experience testing that there are still a few areas where we can improve. And it takes time, actually, creating documentation. So it's a continuous process for us. We will continue to enhance the documentation. Improve code quality improvement. So we do, Michael also mentioned this yesterday, right? So we do some of this already internally, like running clockwork, protect scans and things like that. We have an automated BAT setup also. We like to improve what we have and then start publishing this as well. So don't hold me to this. Like one of the thinking that we had was, okay, how about we do a quarterly major validation? That will be a BAT running every day. But it's an open source code, and our hope is more people will contribute. So how about we run a quarterly major validation cycle and publish everything out there? So you take this version of the source, and you have the validation reports and everything with you, so you know what is working, what is not, right? So it helps you to plan your work ahead. And call to action, try out Slim Bootloader, participate and contribute to the open source community. And as I mentioned earlier, we really appreciate your valuable feedback and contributions. So there is a mailing list. You can get the source directly from the GitHub, and there is an issue tracking mechanism as well. So we'd love to hear from you. Thank you. Any questions?
Thank you. Please give another round of applause. And now we have time for, I think, 12 questions. So please, if you have any questions, yeah, this very specific numbers, right? So if you have any questions, please go stand up to the microphones and.
So Ravi, you mentioned about some platform configuration checker or something. Can you throw more light on that?
Yeah, so it's a platform configuration. It's part of the Slim Bootloader project itself. There is a tool called config edit. It's a Python-based tool. As part of a board support package, for example, let's say we support Whiskey Lake, we publish a set of configurations. It's very similar to FSP UPD. It's kind of similar to that. So we publish a set of configuration parameters. You can use the tool to open the configuration parameters. You set, let's say you're developing your own board, and your board has a board ID, platform ID. You can change the platform ID, and you can change the configuration, and then restitch. During runtime, Slim Bootloader will read the platform ID from your board, and it will match one of the existing platform configuration data set, and it will apply that. And later today, at 11 o'clock or something?
Yeah, do stay tuned for the third presentation. I'll do a simple demo of the configuration editor tool, and you can get a good picture of what it does.
Yeah.
Okay.
Hi. So yesterday I saw a talk about Min platform, and today we're talking about Slim Bootloader. Can you elaborate about what overlap or intersection there is between the two, if any?
Yeah, so Min platform is a native EDK2 project, right? So everything is done in the EDK2 framework. Slim Bootloader, on the other hand, follows the idea of initialization phase first, and then OS boot logic separate. It's like a initialization followed by payload. That's the main architectural difference. Use case wise, there are differences. For example, I'll put it this way. Let's say if I think I saw in one presentation yesterday that the Linux boot was, automotive Linux boot was done in 800 milliseconds or something like that. So that exactly is the use case for Slim Bootloader, where I don't need UEFI. I'm booting either a real-time operating system, I'm booting a VxWorks or QNX or something like that. I don't need UEFI. I don't need UEFI runtime services, but I want initialization launching the operating system. So Slim Bootloader fits that case. Slim Bootloader plus UEFI payload can boot an UEFI operating system like Windows. That's where it's like, I don't know, it's a personal choice kind of thing. Like it's a little difficult to answer that part, yeah.
We have 9.72 questions left.
It's a shame. I actually had 10 questions, but I'll have to limit
10.
it. How big is Slim Bootloader? I gather it's slim.
It is.
Ignoring the FSP and all that stuff, roughly how big is the binary?
So we have as you said, so FSP, you have to ignore FSP, and then if you ignore the redundancy, it should not be, Maurice, do you have the number?
It depends on absolutely, I can tell you the primary firmware, including speed and other CSMD component movement, is around 300.
300 to 400K?
Okay.
Yeah.
Thank you.
All right, two questions here.
Sure.
First, you mentioned the IFWI packaging has the fit tool in it. Does that mean you have a Linux version of fit in there?
Linux version of fit is available for Apollo Lake. I don't know if it's available for Whiskey Lake, Coffee Lake, Refresh.
Well, if you're going to spread this across your entire roadmap, I would be kind of right.
Yes. So that is our intent as well. So we have communicated that within Intel. So we want a Linux version of the whole building should be done in Linux. Is our goal. Yeah.
All right. Second question. You're building Slim Bootloader in basically an EDK2 tree, right?
Not necessarily. So we leverage the EDK to build infrastructure.
Build infrastructure, sure.
Yeah.
Now, can I build both my payload and my Slim Boot out of the same tree in the same build?
You can build the OS loader and UEFI payload. So it's a separate build, but you can use the same build infrastructure to
I
build.
have to run and make twice, or build twice.
Which one? Which payload? Specific payload?
OS payload.
OS payload. It can be one build.
It can be one build.
Yeah.
Okay. Thank you.
2 Pi questions left.
We'll be available here. So if you have any more questions, you can. And there are a couple of more sessions as well that will cover a little bit more about Slim Bootloader. So please feel free to ask us something. Thank you.
Yeah, let's have another round of applause. Thank you.